Welcome back, everybody, to day 16 of Foundations of Programming. This is the final week that we have. I believe that all three of you guys start next week. Very exciting. Today's going to be the last day that we're going to be working on Space Invaders. Hopefully, we can get through it by the middle of today's timeline. And then we should be starting Big O notation um, and common problem solving formulas. Um, We'll speak more on Big O notation once we get to it. But although I did mention that the biggest part of this course was object-oriented programming, Big O notation, data structures, and data types are still a very important subject because, for one, are any of you guys familiar with Big O notation? Have you heard it? I'm assuming you've heard it kind of a little bit. Okay. Yeah. So, it's how we calculate how efficient code is, right? And it's important because it gets you thinking, especially at this time of your journey, what your code is really doing, right? Whether it's it might get from point A to point B, but the steps that you get there might differ from person to person. As we've seen throughout this course, you guys show me your example results or your examples, I'll show you mine, and everybody has something slightly different. Um, and there is such thing as code efficiency. So we're gonna be talking about that, how to, know what method that you're using is more efficient and which one to go with to increase either the time complexity or space complexity. We're going to be talking about some common problem solving patterns that you can use to solve some of these issues that you might encounter when working with algorithms. Um, and once again, reiterating what I've mentioned in the past is that your first gate upon graduating from Platoon is that first technical interview, right? Uh, Unlike other places, if you were to go and get interviewed by somebody, you sit there and they'll ask you some questions about your past, who you are, maybe some situational questions. Uh, as software engineers, we have to go through the technical portion. We're typically given some kind of algorithm to solve um, in front of either one software engineer or sometimes even a board of software engineers in one round or multiple rounds, right? Because it's very difficult to know if you know what you're doing, right? Because anybody can walk through a YouTube tutorial and make a project and they say, "Hey, I built this," right? But they just like walk through a YouTube tutorial. So there has to be a way to see how you guys who you might not have a college degree in computer science, how well you are in your skills that you do. So we'll be talking about that once we start that, and then working on these problem solving patterns. But without further ado, let's go ahead and kind of start off from where we left off yesterday. No, sorry, not yesterday. It was Friday. Let me go ahead and share my screen. We should all be looking at my main.py. If, for example, Kenny, were you able to get most of this done? Kenny said, I missed Friday. Was Friday just Space Invaders? It was. Um, what I can do is I can drop the code. So you kind of follow along, but I'm not quite sure how much you understand of it all. Because there's some things that are a little let's go. Yeah, you said I had this weekend. Did you do it, Kenny? Is that a green light on that? Oh, you had a weekend drill. Okay, that's understandable.
I mean, we also went over the stat data, assignment as well, like at the beginning
True.
on Friday.
We did go over that on Friday. Kenny, I'm just gonna drop on something for you real quick. Where is Kenny? Welcome. Okay, I'm gonna drop the code for you. The first code block I'm gonna drop you, it's gonna be the main.py, which holds the main portion of our application. And then I'm also gonna drop you the second one, which is a spaceship. in case you want to kind of pick up from where we left off, you can use this code and it should get you working. Kenny, do you have Ubuntu or are you on Mac? Thanks. Okay. Using Replit since my Ubuntu has not been working. Ooh, okay. Then you might not be able to follow along, unfortunately. Uh, we, if you want to hold off, I could definitely spend some time with you later and work on the Ubuntu maybe during our break, see what's going with your Ubuntu. Or even after class, or sometimes out of class if you'd like to. We can definitely get together and figure out what's going on with your setup. That way you're prepared for Monday. But regardless, we're gonna go ahead and continue along. Uh, Kenny, you're more than welcome to kind of watch and see what's going on. I just remember we have the pets assignment that Jason brought up, so we can probably get to the pets at the very end of the assignment, which will be some object-oriented programming you can definitely do with us. But unfortunately, the first part says class, you probably won't be able to complete it because you need to have Pygame installed into your virtual environment. But you are more than welcome to stay here and kind of pick up once we move on to pets. But all right, so we have our main.py here. Just to kind of see where we're at again, I'm gonna go ahead and run this to figure out how this is working or see how far we got. So let me go ahead and run my main.py. And yesterday we got up to this point where we were able to open up a window of our game. We're able to have a background where we establish the window, we set a surface so we can add the background image, and then we created an object of our spaceship. We load up an image into that object, and then we even gave it a move function to allow it to move left, right, up, and down on our screen. I believe the last thing we covered was the left and right limit of our spaceship to ensure it does not exceed the boundaries of our window. The way that we did that was by creating a move function here, which was taking the string of a direction, right? So what was happening whenever the main loop of our game was running in the game object, it was running some kind of a while loop, and what it was doing every time it ran was it was checking for events, and then at some point we grabbed the status of all our keys as well outside of the for loop of the events, which returned to us a dictionary that was holding the statuses of our keys, whether they were true or false, being whether they're being pressed down or not. Whenever a key was being pressed down, it was being reported as true, right? So we would check if something was set to true, and depending what it was, we would run the method of move. If the A key was being pressed down, we called the move method from our spaceship, and we passed in the string of A. Uh, and we use these strings of A, D, W, and S to identify what direction we're moving. And then in turn, we moved it on its X and Y axis, depending on the direction it was going to. And then we also did some kind of an if-else statement here to check whether it's reached a certain limit of the direction on the X and Y axis to stop its movement if it's gone too far. That's pretty much what we got up to this point. Do I have any questions about this before we continue on with the rest of our Pygame lecture?
Um, I, I guess syntactically, I have a question. It's not related to Space Invaders necessarily, but as far as like the double if statements, like is it better to like say if like for example on the definition dot move, if direction equals A and self dot reflect dot X is greater than or equal to 20, then self dot reflects dot X equals -5 as opposed to using like two if statements.
Yeah, you can definitely also do that. It might actually look cleaner. So syntax wise, well, functionality wise, this is the same, right? This is
Okay.
doing the same thing as if you were to have it in one line, right? So efficiency
Yeah.
wise, it's the same. Readability, it's going to be up to you. If you think this looks better and readable, or more readable than what we had initially, then by all means. And I think honestly, it probably does, right? It reduces this to one line or to almost like 8 lines instead of what it looks like might be like 12 additional lines. So yeah, it actually might be better. So whichever way you want to do it, by all means, you can. But it's gonna do the exact same thing. It doesn't increase the functionality of it, but it might make it easier to read. So
Okay.
I do it when I code with you guys. I deliberately code out every single line so I can explain to you what each line is doing. I try not to do too much in one line because then it can get very confusing. We have like too much on something. Um, so I do this to say, hey, we're only gonna do everything within this code block if the direction we're going is A, and then we go into here. Um, I don't know if that helps you guys. If I'm making it more confusing than it has to be, that also might be something that might be happening.
No,
Uh,
it's fine. It's just something I was wondering, but I guess when we get to the big O section, that's when we'll worry more about efficiency as opposed to, things like that, if or if and, that kind of stuff.
yeah, we'll definitely get into that. But even so, this here does not increase the functionality of your code. It will come down to readability at this point. Because when it comes to your code, when you define or when you try to define what is more efficient, I don't believe it's just time efficiency or space efficiency. What you also have to take into consideration is the readability of your code, right? Because let's say you have a very complex kind of solution, it might be very, very efficient, but if it's also way too confusing for everybody else to understand what's happening, then it might not be as helpful for your team. But yeah, hopefully that answers your question. Now, so cool, our spaceship has liftoff. We have everything we need for modern space exploration at this point, right? But still, we don't have some too much of functionality. It's not a complete game. The next thing we're gonna do is we're gonna create a bullet class, right? This is gonna be what our spaceship is gonna use to be able to engage the enemy. To do that, we're gonna create a new file within the same directory, and you can call it whatever you like. You can call it bullet, laser, whatever you want. I'm just gonna call it bullet.py. Here, I'm gonna isolate the code for the bullet, and I'm gonna start a new class called bullet. Now, something to take into consideration when it comes to your bullet class. And this is very Pygame oriented. Um, Unlike our spaceship, that we only have one object of this spaceship, right? It's very easy to control the position of this object, right? It's all linked to the WASD keys. Whenever I press one key, it's only going to move one specific object. The issue we're about to encounter is when we have a multiple of different objects that need to be updated, right? Whereas right now we only have one object, which is our spaceship. When we start using stuff like bullets, right, we are probably going to fire out multiple bullets at a time, right? What if you rapidly press your space bar to shoot 10 times? You're going to create 10 different objects, right? And you need to be able to track the position of all these bullet objects and then update them accordingly, right? Now, we can manually do this ourselves, or we can take advantage of a sprite class that Pygame already comes with, and we're going to inherit from, right? So what we're going to do is, after you define bullet, you're going to open up two parentheses. And what we're about to do is inherit from a class that's already built into Pygame. That way we have the functionality of what's known as a sprite group. Now this class that we're going to inherit from is called Pygame.sprite.sprite, but capital letter on the sprite the second time. So the first sprite is lowercase, the second sprite is capitalized. And I'm getting an error here, and that's probably because I need to import Pygame. And we're going to inherit from this class to receive some already built-in functionality so we don't have to recode it. And I'll explain to you the functionality of what that is in a second. After we start this class, we're going to define the init method. is going to take in self, like always, and we need a space, or I guess the X and Y for the location of where our bullets are going to spawn in. Right. This X and Y is going to be the location of where our spaceship is located at, right? Because ideally, when we press some kind of button, whether it's your space bar, whether it's your mouse click, wherever your spaceship is located at, there should be an object that gets instantiated right at the base or the cannon of where the spaceship is located. And we'll talk about that in a second. But we need to have some kind of location of where we want to instantiate this object. So that's what our X and Y is going to be. And now, to actually use the attributes that belong to sprite.sprite, we're going to initialize the class that we inherit from. So to do that, we have to say pygame.sprite.sprite dot underscore init underscore self. And this is very similar to super.init, if you've seen this before, right? This way we can initialize the data attributes and the methods that come with the class that we're inheriting from. The best way I can explain it is think about it in the case of a superhero, right? Let's say, Jason, your dad was Superman, right? And you're born, but your powers haven't been awakened yet. You're his son, but you don't have access to his abilities, right? At some point in your life, to use them, you have to awaken these abilities, right? Now, in this analogy, you normally just awaken them at a certain period of time, maybe when you age, maybe once you're an adult, or at some point once you hit maybe puberty, you might, initialize these superpowers. That's kind of what we're doing, right? This bullet, it inherited some kind of ability from its parents, which is pygame.sprite.sprite, but we don't have access to its abilities just yet. So we want to initialize or essentially awaken these abilities that come with this sprite class. So that's what we're doing here on line 7. We're going to initialize the abilities that come from this sprite class on line 1. And then what we're going to do is go through the rest of what we did, very similar to the spaceship where we created the image and the rectangle. We're going to do something very similar to the bullet class. Now, I could not find a bullet that I was happy with, like a bullet image. But Pygame has a method of being able to create objects using some commands. Like you can create shapes, like a square, a triangle, a circle. You can create a shape using some code that Pygame has. So not to dwell on the code behind it, I'll just give you the command. But we're going to essentially create the image for our bullet. And instead of loading in an image, we're going to create it ourselves. And the way that we're going to do it is by saying pygame.surface, surface is capitalized. We're going to give it 10, 10, which is the size of our bullet. I believe this stands for like radius or something like that. Or I guess we're no, this is not the radius. This is just the size of the canvas we're trying to create. It's going to be a 10 by 10 square. And then what we are going to do is we're going to pass in pygame.src alpha. This was going to help us create this object that's a shape. Don't worry too much about how this part is working here, this attribute. Just know that we are creating a shape with this. Right? Finally, we are going to say pygame.draw.circle, and we're going to pass in the image, which essentially is just a surface, self.image. And then we're going to give it the color that we want. This color, I believe, is red. This is like the color value. You can already see there the attributes this takes, surface and then color value. So this command here actually draws the circle. So line 9 is creating the surface that we mentioned before, like the layer of where we want to create the circle. And then we are actually going to create the circle and add it to that surface. After the second argument, you're going to add another argument, which is the coordinate of how they should be set onto our surface. We're going to say 5, comma 5. So we want this dead center on our surface. And the second one here, we see it's the radius, right? Because it's a surface, it's going to take a radius, and we're going to give it a radius of 5. And this should not be in parentheses. I think I accidentally put one in parentheses. This is what it should look like. It's one method called dot circle, and it takes 4 arguments. The first argument is the surface you're trying to add to it. The second argument is a parentheses with the color value. The second argument is the location of where you want to put it on the surface. And the fourth argument is the radius of your circle. Right? If I had an image, I wouldn't do it this way. I would do it very similar to how it's being done here, where I load the image and then I give it the rect. But we're manually creating this image here using some commands. That's all we're doing here. So don't dwell on the method itself. Not important. But just like we gave the spaceship a rectangle, we're going to give a rectangle to this bullet so we can handle the collisions of it. So we'll say self.rect is equal to self.image.getRect. All right, so we're going to give this surface an image. And we're going to give it the coordinate of mid-bottom. And it's going to be x, comma, y. Just like we did on the spaceship. These are the attributes of the bullet. So whenever we instantiate this object, it's going to automatically already have a surface. It's going to have an image of a circle. And it's going to have the rectangle to have some kind of collision box. All right. Now let's go back to our main.py. Just like in our main.py, we instantiate the spaceship object. We are now going to have to instantiate our bullet. But this brings it back to what we talked about earlier. We discussed that before it was very easy with just a spaceship, you will just manipulate one single object. That was very easy to keep track of. But what if you have like 10 bullets on your screen? How do you track every single bullet object you instantiated, right? And to do that, what we're going to do is create a group. So we're going to create a data member here called self._all bullets. And this is essentially a dictionary in a sense, or some kind of like data structure that we can hold multiple different objects. So again, it's like a dictionary or a list essentially. And what we're going to assign to this data attribute is pygame.sprite.group. And I wonder if I can see what exactly it is. I'll show you exactly what it is in a bit. But when the definition has it. Oh, it's a set. It creates a set. Right, this is the data structure that it is. It creates a set for you. And there's a reason for that. Right? Once we create this set, we're going to be able to add multiple objects to this set. And we can run a method that will update every single object within this set. Right? So instead of individually grabbing every single bullet and then updating its X and Y axis so we can move, we can put it in some kind of data structure like a set, run the method on the entirety of the set to update every single item within this set. Everyone still with me? All right. Well, with the set here, I'm going to come down here to where my event type is at. And if you recall, we have the mouse button set up. So when I click on my screen, it does something. So right now, I've already been tracking the mouse button down, but it wasn't doing anything fancy. It was just printing out mouse is down. Now we're actually going to add some functionality here. What I want to happen is every time I click this button, I want for an object of a bullet to be instantiated, right? I want to create a instance of a bullet. Right? So what I'll say is bullet object is equal to, and then I want to call my bullet class so that every time I press this mouse button, it's going to create a new bullet object, and I got to import it. So I'm gonna say from bullet imports bullet, so I can use the object. And now every time I press my mouse button, it's going to create a new bullet object and save it into this bullet object variable. So what does bullet take? It takes the X and the Y axis, right? Because that's what we define for the enigma to have. What X and Y axis should we give this?
The ships. So it looks like it's coming out of the ship.
Correct, right? We want to grab the ship location. Well, how do we grab the X and Y axis of our spaceship? We created a getter method, if you remember, called get position, that once again returns a data member or data attribute that belongs to our object. So we can use these getter methods to get the X and Y axis of our rectangle that's on our spaceship, and then pass that into our bullet object so it knows where to spawn. So I'll say something like this, where ship chord is equal to self.ship.get position. Right? So I call the object of ship that we created earlier. I use the getter method, which is going to return to me the X and Y axis of ship chord. And this should be a tuple, right? And to access animate tuples, you access them very similar to a list, use index notation. So I can say, this is going to have a tuple of X and Y. So ship chord index 0 will give me the X, and ship chord of index 1 will give me the Y. So using this variable, I'm going to pass it in. I'm going to say ship chord index 0, and then ship chord index 1. So every time I press this button, it's going to grab the current position of the ship of when I press the button. It's going to pass it into my object and instantiate this object. Now, once I create this object, what I need to do is keep track of the object. So we're going to add it to the set that we created, which is all bullets. And to add something to a set, and this is going to be very similar to how you're going to do it in Django as well. To add things to a set, you have to say add, right? So we're going to say self dot all bullets dot add. And we're going to add the bullet object.
So it has to be all bullets, not add bullets. Self.all bullets.
Self dot all bullets. Yes.
Oh, down here, I mean, on line 33.
Yes. I don't know why this is grayed out, if I'm being honest with you. Could have all bullets here. We'll see if it causes any issues.
No, I guess I'm confused. Is it supposed to be self.add bullets down here on line 33? Or all
Oh,
bullets as opposed to add bullets? Is
all
what I'm
bullets.
trying to
That's why it
Oh,
was grayed out. Thank
sorry.
you. Thank you for that. You just saved me some headache. Yes, that's why it wasn't working. I'm calling this set that we created earlier. And this set has a function called add. Right? To add things into a set, and this is basic Python. To add things to a set, you can use add. It's going to add that bullet object into that group. Right? And every time I create a new bullet, I'm going to add it to this group. And this is going to come in handy in a bit. So once it's been created, the next thing to do is to actually draw it on our canvas. So what we're going to do is down here where we're drawing everything else, we're going to draw our bullets on our screen. So we're going to call the group self dot bullets, and we're going to use the method self dot draw. This is a built-in function that comes with the sprite group, which is why we're inheriting from pygame.sprite.sprite, so we can utilize this function. It's going to take in a surface, and then using the surface, it's going to grab everything that's within this set of bullets. It's going to draw it on the surface that we passed in. And now, if I run this, what's going to happen is when I press this, you see that it's drawing the bullet on my screen. Now, it's not perfect, and we'll get to that in a bit. Notice that I draw it, but they're not moving, but they're also offset. They're to the left because it's taking the top left corner of my spaceship coordinate location. So we have to fix that. We're gonna have to do some kind of messing around with it. But every time I press this button, it creates a new bullet object. It adds it to the set of all bullets. And then as my loop is running, I'm calling the bullet set using the dot draw method, and I'm drawing it on the space surface. Right? So it's working so far. Everyone got this? I'll take Tim's silence as compliance. All right. So let's do a little bit of manipulating because it's not perfect. It obviously needs some tweaking. So let's go back to the coordinates of that we passed in here to our bullet. Let's add some functionality. The x-axis is a little bit to the left of where the spaceship is. I need to move it to the right. So I'm just going to do plus 40 on the x coordinate. And the y coordinate should be kind of fine. I'll see what it looks like. But if I run this, now it's right in front of the cannon of my spaceship. It's a little too above. I could probably bring it down a tad bit and say something like maybe plus 10 on the y coordinate so I can bring it down. And there you go. It's dead center in the middle of where the cannon is at. So every time I press this and I create a new bullet object, it's going to find the location of my spaceship. It's going to tweak it by 40 on the x-axis, 10 on the y-axis, and it should be right on point of my cannon. Everyone good so far? All right. Well, we inherited from this class for a reason, right? The sprite reason. And we're about to see the biggest reason why we inherit from this class. Well, this class comes with a method called update. So if you go back to your bullet object class definition, I want you to write out the class update. Normally, the update class by default has nothing, but we're able to override it. Right? We inherit from our parent pygame.sprite.sprite, and now I want to override it. What I want this to do is every time that I call the update method, I want to update the y-axis, which is up and down, and subtract 5 from it. So every time I run this update method, it's going to grab the bullet object and update its y coordinate. And once again, this update is going to run with our game loop. So it's going to continuously move our bullet as we go. So every single bullet object has this method called update that we just defined. And to run it on every single object in our sprite group, what we are going to say is self dot bullets dot update. So we call the set of all the bullets and we run the dot update method. This is going to invoke the update method from every single object of bullets within our set. This is the reason why we inherited from the Pygame sprite group. That way we can update a large group of multiple objects. Unlike the spaceship, which was just one singular object, we were able to manipulate that individual one because we have multiple instances of this bullet. We need a way to update every single one continuously. And this group that we created is going to allow us to do it by invoking a method that it has, which is update. And as we already defined, update is going to change the y coordinate for our bullet. And now, if I run this, and I press my mouse, we now see the bullets going through outer space. Isn't that cool? Do I have any questions on the bullet class or the update class? Now, what do you think's happening whenever my bullets reach the top of the screen?
Well, we don't have a limit on how high it can go.
Yeah, well, let's do something. Every time I click my mouse button, I want to print out self.all bullets, right? This is the group that's holding my bullet classes. Let's see what that looks like. Look at my terminal here. When I press it, oh, I didn't put print, my bad. Let's print. We're gonna print out this set of bullets, right? We printed out before we created one and it showed 0 sprites. The next time I put it, or I press the button, we see that this group has 1 sprite, 2 sprites, 3 sprites, so on and so forth. And notice every time I'm updating or I'm clicking this, it's going to show me the updated value of how many sprites we have in that group. They're no longer in our screen, but this group's still showing there's over 50 sprites. Nothing's actually happening to these bullets. They're going all the way through our screen. And although we don't visually see it, they still exist in memory. Right? And that's problematic. We have a bunch of objects that are still created and being tracked, but they're not needed any longer. So we have to fix that, right? Because if you're playing this game for an hour or two, you're probably gonna have thousands upon thousands of bullets spawned into your memory that you are tracking, and it's gonna mess with the functionality of your game. So to fix that, on the update method, what I'm gonna do is I'm gonna say if self.rec.y is equal to, let's say, -10. -10 is going to be up above outside of my window. If the y-axis of bullet is equal to -10, I want to say self.kill. This is a method that comes with the Pygame sprite class. And what it does is it checks if we meet this condition where the y-axis is equal to -10, and if so, it's going to delete it. It's going to delete it from the group. And now if I run this again, I see here that once they're out, notice how my group dropped back down to just the ones that we have on the screen. So now, whenever they exceed the limit of my game window, I no longer track them. And look, the rate that I'm firing does not go past 8 or around 7 because they're deleting just as fast. So self.kill is kind of like using delete on a list or a dictionary. All we're doing is just removing it from our data structure. Any questions? All right, let's go ahead and move forward. We're gonna create the alien for our game. So far, so good. We have a background, we have our spaceship, we have some movement, and we have a group of different objects being instantiated to represent our bullet. But it's no fun if we're not actually hitting something, right? This is not a really interactive game. So we're going to create our alien. So in our lesson 10 directory, I want you to create a new file called alien.py. Once again, we're going to import pygame. I'm going to create the class of alien. And what do you think we're going to do to this alien as well?
Inherit something.
Yeah, we're going to have to inherit from the sprite class again, because we might have multiple aliens instantiated that we need to keep track of. So because of that, I'm going to inherit from pygame.sprite capitalized. So I can take advantage of that update method the same way that I did on the alien, on the bullet class. So we're going to define the init method, which is self, and we're going to give it nothing else, just self. We're going to go ahead and awaken our powers from our parent class by saying pygame.sprite.sprite._init_self. Now, the reason why we're not going to give our alien an X and Y coordinate is because what we're going to do is we're going to make him spawn from the top left of our screen, go right, and then continue down the screen. They should all come from the same area, so no biggie. Now, you can give it an X, Y coordinate and make it spawn from a very random locations, but we're not going to do that. We're going to keep it simple. And now what we're going to do is we're going to create 3 different data members for each type of alien that we have. We're going to say self.green alien. And we're going to do this just like the spaceship. We're going to do pygame.image.load. Right? And this took in an image. Now, we're not going to pass the image as an argument like we did the spaceship. What we're going to do here, we're going to go ahead and just hard code it in here. For the green alien, we're going to use the assets directory that we have in lesson 10. And this is going to have the file for our aliens. We're going to say assets/green alien.png. We're just going to directly bring in the alien picture for this alien, the green one. We're going to do the exact same thing for red alien and then for yellow alien. The only thing you're going to change is the file path to its corresponding picture. And now, we are going to identify which alien we're going to use. Who could think of a way of how we can choose the alien that we want? Right? We need to take one of these images and create some kind of rectangle for it and instantiate it. But it's probably not that cool or fun to just have the same type of alien being instantiated every single time. Right? Imagine just a bunch of red aliens. That's not really fun. We should have a variety. Different aliens with maybe different health that take different amount of attacks. They might have different attack patterns if they wanted to. How can we choose which one that we want?
I mean, if you want to make it a surprise, could do like some kind of like random method.
Yeah, we can do like a random method. We can say something like self dot spawnable aliens is equal to, and then what we'll do here is pass in the red alien, the green alien, and the yellow alien. within this list. Right? So this list will hold all three of these images. And now we can use this list to choose a random one. So utilizing the Python random module, I'm going to say import random, I can choose which one of these images I want to use for this specific object. So I'll say self.image is equal to, and then I'm going to call the spawnable aliens. But for the index that I'm going to pass in here, I'm going to say random.randint, and I'll pass from 0 to 2. I'm going to start at 0 and go up to 2. Notice that this is including both endpoints. So it's not up to and not including. Whatever number you pass in as a second argument, it's going to include that number too. So it's not like the range method where it's up to but not included. This one will include it. So this here, whenever this runs, is going to select one of these by random using the random integer and assign it to the data attribute of image. So every time we create a new alien object, it's going to choose one of these pictures to represent it. And just like the spaceship, we're going to create a rectangle. Self.rect is equal to self.image.getRect. And for this one, we're going to say center is equal to 2020. No specific reason for it. It's just how I decided to grab the alien rectangle and manipulate it on my screen. You can use mid-bottom, you can use top, however you want. You would just have to do some messing around with it to ensure it appears exactly how you want it on your screen. But same thing as we did for the spaceship, we created a rectangle to let it know where we want to place it on our screen. And this is good for now. This is the bare minimum that we need for this alien. We're able to create the image by loading in all three of these images and then choosing one by random and then giving it a rectangle. Is everyone good here before I move forward? Okay. All right, returning to the main.py, very similar to how we created a bullet group, we're going to create an alien group. So we'll say self.allaliens and use the sprite group method that we use for a bullet here as well. So we can keep track of all our aliens. Now, our bullet class, the way that it worked is every time that we clicked our mouse button, it created a new bullet object. Well, we don't want to do that, right? We don't want to have to manually spawn each alien. We want it to happen on its own. So this is not relevant to anything object-oriented programming. This is a Pygame thing, but we want to create a timer, right? A timer that we can use to track how often I want to spawn these aliens. So to do that, we're going to say self.enemy spawn timer is equal to pygame.user event in all caps plus 1. What this does, the pygame.user event is going to grab all the built-in user events that the game already has that come by default, but we're going to create a custom one. Once again, this is not related to object-oriented programming. This is strictly a Pygame thing, so we can move forward with this. Just know that this creates some kind of event that we can track, that we can force to happen. And then after we create the spawn timer, we have to start it. So we're going to say pygame.time.setTimer. We're going to pass in the timer that we're trying to set, which is the self.enemy spawn timer. And I want to do it every 2,000 milliseconds. So every like 2 seconds. Right, we're manually creating some kind of event that's going to happen on our game every 2,000 milliseconds. That's all this is doing. Now, let's come down here to our events. Right? we have an event that exits out of our game. We're tracking if one of the events is a mouse button. Now that we have this event that we created, we can also track this one the same way that we're tracking all the other events. We created an event ourselves. We had some already that came built in. One was like pygame.quit. One was the event of clicking your mouse. We just created a manual one called an enemy spawn timer. That's essentially what we did. So we're going to say if event.type is equal to self.enemy spawn timer, right? We manually created an event and that got added to the dictionary of all the Pygame events that Pygame is tracking. Now we can use that event that we created to track the status of it. And what's going to happen that every time this event is triggered, I want to be able to create an alien. So I'm going to say alien object is equal to alien. And again, it's here because I need to import alien. So from alien, import alien. Once I create that alien object, just like the bullet, I'm going to add it to my all aliens group or sets to be specific by using the set method. And I'm going to pass in the alien object that was created. And just like I was able to draw all the bullets using the update method and the draw method, I'm going to do that as well. Draw our aliens. I'm going to say self.allaliens.draw, pass in the space surface that we are trying to draw everything on. And we'll keep track of the update method in a little bit. Let's just draw it for now. The only thing different from this and the bullet was the fact that we created a very unique event to keep track of this. So we don't manually do it ourselves with a mouse event, right? Everything else is still the same. We inherited from a different class that Pygame has. We gave it some kind of image. Where the bullet, we created the circle here. We already have the images, so we just loaded up the images. And then when we instantiated the objects, we added it to a group that has the method of draw. And now if I run this, we should see at the top left the images of all the aliens spawning. All right. Does everyone have this so far? Let me move this to the left so you guys can see my code if needed.
Yeah, I think I made a typo somewhere.
Okay. Tim?
The random that we use for the alien generation, it takes how many arguments?
It takes two. Let me show you. You call the random.randint. You probably use a different method, not randint. That's probably what you're getting.
Yep, I did. I used random.random.
Yeah. What's the type, Jason? You encounter it?
Oh, I figured it out. I just used error messages and I tracked, a couple errors down, and now it seems to be working.
That's what I'm talking about, baby. All right. Yeah, so we got something working here, guys. Now, here comes the next part. The update method. So just like the bullet class has the update method because it's inheriting from pygame.sprite.sprite, so does alien, right? We're going to use that update method to also move our alien class. So we're going to come down to our alien. We're going to say define update. And now, here's going to come the first assignment. Your assignment is to make these move. You already did something very similar to the aliens, right? You know how to move the X and Y axis. The intent for this one, let me just put pass for now, And also make sure you add the self.allaliens.update here, so you don't forget it. After we draw them, we're going to update them as well. Right? But I want you guys to override this update method and add some functionality. What should happen is that the aliens are going to spawn and they should move right. But once they reach the right parts, they need to shift down and then move left. Once they reach the far left, they need to shift down a little bit and then move right. They're going to snake their way all the way to the bottom until they eventually reach our main character. Right? So we pretty much have the entire infrastructure of our alien complete. We just need the functionality of them moving. So using the update method, I need you guys to manipulate their movement to replicate that snaking pattern on your screen. Hence, you can create variables or data attributes to track what direction an alien is going in. And once it reaches a certain part on their x-axis, you can switch that variable to now represent that's going left. And while this variable is true that it's going left, you will go to the left by changing the x-axis again. And so on and so forth. Right? For the most part, it needs to shift the x-axis, but once it reaches the far edge, you need to shift the y-axis and then go the opposite way. Time is 6:27. Go on a 10-minute break to 6:37, and then come back, give it 10 minutes, and then we'll come back at 6:47. I'll see you guys then. Were you guys able to solve it? Okay. All right. Well, let's talk.
I mean, yeah, I tried to do like a while loop, but it was pretty much running an infinite loop, and I couldn't get it to work.
Getting
Yeah.
it to move was easy enough, but getting it to reverse course when it hit the edge and then drop down a row is challenging.
Okay. Yeah. So no while loop is needed here, Jason. Why? Because we already have a while loop running. The while loop runs continuously in this run function, right? Until we quit. So there's already something running the update method over and over and over again. That's how everything else is working, how we're checking every single event, how we're moving the spaceship, right? And we're already drawing the aliens. And this update method is already running in a while loop. You don't have to add another while loop because it's still doing that, right? It's already running in a while loop itself. Now, everything you do here is going to keep doing it. For example, print. Oh, my keyboard turned off. Give me a second. Print. I am an alien and I'm moving. All right. When I run this, there it goes. Now you see it being printed out. It continuously printed out the update method because there is an alien here now. So this will continue working. It's already in a while loop, so you don't have to add no kind of loop. Just add the functionality itself. It's already set up for you. Now, the actual movement. How can we do that? Well, I mentioned that you might want to keep track of what direction we're moving and what direction, how much to move in each direction. So what I'm going to do is I'm going to create a variable called self.going right is equal to true. By default, every time an alien spawns, it should already be set to true because they're only going to go right. Right, so I'm going to use this variable here to keep track of what direction each alien is moving. Now, whether this is true or false is going to depend on what point they are in the game, because this is not always going to be set to true. And what I'm going to do is, if self.going right is equal to true, then that means I am going right, so I should act like it. Right? I should move my x-axis to the positive, so it shifts across my screen to the right side. So if it's equal to true, I should say self.rect.x plus equals, we'll say 5 for now. Right? And we can see that here. if I come down here and run this again, it's gonna spawn my aliens. It's gonna run the update method, and now they're moving. They're all moving to the right because they're all equal to true. So like Tim said, moving to the right it's easy, all right? So we have that, so we can shift them to the right, and now what we can do is say if self.rect.x is equal to, you can say 800, right? Which is the far right limit. Then we can say, what should we do, right? If they're already at the edge, what needs to happen? Well, one, they have to shift downwards a little bit, and then they have to start going left. So let's do that. If the x-axis for the alien is true, I'm going to say self.rect.y plus equals, and let's say 50, right? Because remember, y-axis from top to bottom, going up is negative, going down is positive. So if I want it to go down, I have to increase my y-axis. So if I'm at the far right edge of my screen, I need to shift downwards, and then I have to do something else. Well, now that I'm this far in and I've shifted downwards, what I'm going to do is say self dot going right is equal to false. So the next time it runs this update method, it's not going to do everything within this code block from line 22 to 25 because it won't pass this check because it's not equal to true, it's equal to false. And if it's equal to false, that means I'm going left, right? Because going right is equal to false. So if I'm going left, I need to do something else different than what I was doing when I was going right. So I'll say self.rect.x minus equals 5. Now I'm subtracting my x-axis and shifting left. And let's see how this looks like so far without doing anything else. When I run this, it spawns my aliens. They get to the far right, they shift downwards, and they come down. But that's all they're doing so far. Because after this, the self dot going right is equal to false, and that means they're going left. At no point do I ever go right again. So now we have to finish the functionality on the left side. If self.rect.x is equal to, let's say, 0, then I need to shift down. And now go right. So the same functionality that I pretty much did it on the right side, but now I'm doing it on the left side and going the opposite way. And just interchangeably going between false and true to replicate going left or right. And now, when I run this, you see my alien goes to the far right, it shifts down, goes to the left, shifts down, goes back to the right. Now, the right one is a little too far out. It goes out of my screen, where this one, it does reach the edge, and then it shifts down. I don't want it to go out of my screen before it shifts. Let's adjust this a little bit. Instead of going to 800, let's say up to 760. And maybe now it's a little bit better. Let's see if it goes out of my screen. No, there we go. Now it goes right to the edge and shifts downwards. So now that event that's being tracked, at every 2 seconds, it's spawning a new alien that is being updated continuously to move over and over again. Pretty cool. Is it simple enough now?
Could you go back to your declaration of your self dot move right?
Yeah. So depending what side we're moving, left or right, we're going to do one thing or the other. Right? If we're moving right, then my x-axis needs to increase. If I reach the far edge, I need to go downward and then start going left again. And then
I'm getting
Sorry.
I'm getting an error saying that I don't have the alien object doesn't have the attribute for going right.
Did you assign it into the init method?
Oh, that's probably an issue. Yep, that's my problem.
Jason?
Oh, I was just gonna say, if you wanted to slow down, would you just decrease the self.rect.x to like
Yeah,
plus equals 3 or something like that?
correct. If you want to slow it down, then you can make it just move one pixel at a time, right? We can set this to 1, and it's gonna be painfully slow, but it does work. It's continuously run this update method, but now the amount of times it's shifting to the right is not as big as it was when it was on 5.
Well, geez, I guess that's all we'd have to do is just change the self.rect.x method to make it harder or easier mode.
Yeah. And see, what you can also do, right, is you can do something if you wanted to expand on this project. You can say self.health is equal to 100. And then when we add the functionality for fighting, whenever we collide with a bullet, if you want to give them more, like, to do less damage, you can say, like, every time they get hit, it subtracts, 50 from here. And then once it reaches 0, that's when you kill this object. Right? So you can add more functionality here and make it more realistically like to what a real game will be like. You can increase your movement speed. You can make health packs that you can pick up to increase the movement speed of your data attribute for your hero to make it go faster, shoot faster, right? It's a bunch of if-else statements if you think about it. This is all it really is. This is all within a while loop, and it's a bunch of if-else statements, right? A bunch of if I'm doing this, then do that. If I'm not, then do the other. And you're just constantly doing something over and over again in a loop, checking what's happening now. Very, very simple. All right, let's go ahead and continue on. We're close to finishing this assignment. So we were able to add the functionality of our aliens. Good so far. But when I run this, and let's move this back to 5, because it's a little too slow for my liking. I have my bullet class, but when it interacts with an alien, nothing happens. So although we have an enemy, we have a hero, we have a way to attack, this really isn't that interactive yet. We have no way of actually winning. So let's fix that functionality. First and foremost, I'm going to delete this print statement on my groups. I don't need this. If I did a print statement on the all aliens group, it will show something very similar to that, sprites of aliens. But now let's actually do some functionality of what happens when a bullet hits my alien. Well, what we're going to do is we need to update our bullet class. So we're going to go to the bullet class. And what we're going to do in this update method is we're going to pass in a new argument. And we're going to pass in the alien group attribute. Right? And the reason we're doing this is because when I update a bullet, I want to check if this bullet is colliding with any alien within the alien group that we have. So to do that, you have to take one group, take the other group, and compare both groups to say, hey, are their X and Y coordinates the same at any point? If they are touching, I need you to remove them off my game. So don't forget on your main.py, make sure that you pass in this new parameter of the alien group. So in our main.py, go to the all bullets update line, and I need you to pass in self dot all aliens, right? That alien set that's holding all our sprites, we're going to pass it in as an argument to our bullet update method. So every time our bullet is moving, we're also going to compare it to the other group to see, hey, I know you're moving, right? Cool. But have you came in contact with anybody of the enemy? Have you actually collided with anybody? Have we hit them? So how do we do that in the update method? Well, the way that is done is by calling a command using pygame.sprite.sprite collide, all lowercase, sprite collide. This takes two different sprite groups and it compares them. Well, the class that we're defining this is already going to be a sprite, so we can say self. I want to check against the alien group I'm passing as the parameter. And then the third argument we're going to pass in is a Boolean. True or false, do kill is what the argument is. What this is saying is, if I collide, should I destroy the object or not? And we're going to set it to true. That way, when it collides, when whatever is passing to the first argument collides to the second argument, it's going to delete that second argument from the game. And now, if I run this, you'll see here that we get the alien, and the moment it touches one of the aliens, it disappears from my screen. You don't have to run the self.kill method on the alien group. The sprite collide does that for you on the attribute that you passed in true in. And now the aliens are no more. Well, how do we lose? We have a way of winning, but we don't have a way of losing. Well, what we need to do is we need to update what happens if I collide with an alien. So in our main.py.
So I sorry to interrupt. I don't know if we got this complicated, but I just noticed like, bullet will keep going. So even if it hits an alien, it'll keep going up. It's a pretty strong bullet.
Yeah, I could go deeper to it. I could find a way to remove it with the sprite collide. I don't remember all the parameters in there. If you want to, find more about this, I encourage you to check documentation. But yeah, it does go through it. It will delete the bullet when it does exit out of the screen, but it won't be destroyed right now. Whenever it collides with an alien, I would assume that you could probably pass in some kind of argument in the sprite collide to delete both of them. Let's see. Let's hover over, go to definition. And you can even see the definition here. It finds sprites in a group that intersect another sprite. Return a list containing all sprites in a group that intersect with another sprite. Intersection is determined by comparing the sprite.rect attribute. See, this is exactly what I was telling you about. It's looking for the .rect. The do kill argument is a boolean. If set to true, all sprites that collide will be removed from the group. If collide argument is a callback, well, I didn't delete the bullet. So what's going on with that? Let's see, where is the collide? Collide equals none. Do kill enemy. I would have to look more into documentation, but it's okay. Maybe group collide is another one. We could probably do group collide. But this will require us to check it differently. But we won't get too much into this. Let's get back to the main.py. So very similar to how we checked if a bullet is intersecting with an alien, we're gonna do the same thing but for a ship. The reason why we're doing this is so we don't just go on an infinite loop. We have to find a way to die. But we're not gonna do this within the spaceship class. We're gonna do it in our main.py. To not get sidetracked, I won't explain exactly why we're doing that. It has to do more with the functionality of the fact that the spaceship isn't a sprite. Because it's not in a sprite group and it's not being inherited from the sprite class. So you can't treat the spaceship exactly like a sprite. So this one's a little bit different. I won't get into nitty gritty of it because it's not a Pygame lecture. It's just like an object-oriented lecture. So in the main.py, at the very end, I'm going to say if pygame.sprite.sprite collide. I'm going to pass in the spaceship. I'm going to pass in all aliens. And I'm going to set this to false. I'm not going to destroy anything, but what I'm going to do is I'm going to say pygame.quit and sys.exit. The same functionality that I did when I pressed the X button, I'm going to run that same functionality if I encounter an alien that touches me. And I'm just doing this to have some way to exit out and lose. This is not like an ideal way, but it gets the job done for now without adding more content to it and wasting time. But notice here's the aliens, and the moment it comes in contact with me, it exits out. Now you can add a dev screen, you can add some multiple lives, reset him to the start position. You can add more functionality to that. If you want to continue on this project on your own, I encourage it. You can kind of mess around with this and see what else you can do with it. But we'll keep it simple. And there you go. We have an entire game, right? From start to finish, we can spawn in, aliens come in, we attack them, and then they can attack us. We obviously have the advantage because we got long range, so they have to move their way to us. But congratulations, you have completed your very first game using Pygame and Python. Congratulations. Any thoughts, comments, complaints?
Yeah, it seems like I missed a step. My aliens are not dying when I hit them.
It needs to exit out. If you want to die, you would put true. Or are you talking about the
No, the bullets
bullet
are not killing anything.
Oh, okay. In the bullet class, you have to set this to true. It should look very similar to this. Pygame.sprite collide. That first one is going to be self, right? Because whatever bullet touches it should do it. Or, I'm sorry, and you do alien group at the second argument, and then true, so you can kill the sprite. Kenny, good timing. We're about to start pretty soon on pets, so don't fret. We're about 10 to 15 minutes close to finishing this lecture on Pygame. So just bear with me, and then we will start the next part of the class. Thanks for coming back, Kenny. Nice to see the dedication. Is that working, Tim?
No, it's saying that argument doesn't exist for alien group. So where I'm calling it, I must have not passed it. So I'm looking for that.
In updates. You have to pass it in self.bullets updates. Pass in the alien group. Self.allaliens.
Is that a bullet or main?
In main. In main, in the while loop, wherever we're drawing the bullet group and we're updating it, there you're gonna pass in the argument of all aliens. Make sense?
No, I'm not seeing it.
Okay, go ahead and share your screen. Right here. All your bullets. Whenever you update a bullet, you're gonna pass in the alien group, self.allaliens. Working?
Yep, that worked.
Right on. All right. To finish this up, we're gonna do something very quickly, just so it's not very quiet on your end. We're going to fine tune it, give it a little bit of atmosphere. At the very top in your main.py, let me share my screen. At the very top of your main.py, where you set the mode, we're gonna do one thing. We're gonna say pygame.display.set caption. And I just want you to put Space Invaders. What this is gonna do is exactly what you think. It's going to change the name on top to say Space Invaders. Nothing crazy, just some appearance-wise, right? Give the name to your game. So we'll set the caption. And now, finally, what we're going to do is going to add some sounds to it very quickly before we finish here. That way, there's some kind of environment happening. The way that we're going to do that is after clock, and it doesn't really matter in what order you set its attributes. I'm just trying to keep it all within like, a certain section like, hey, here's all the settings for the window. Here's my spaceship. Here's my bullets. Here's my aliens, right? So no real reason of order of where this goes in the method. I just like to keep my things organized. But in the settings of where I'm creating my window, I'm going to say self.channels is equal to pygame.mixer.set num channels. And I'm gonna set 2 channels here. What I'm doing here is I'm gonna add some sound. But the way that this works is that by default, there's only one socket where you can play music by default, right? That's like the main socket, the main channel. If you want to add multiple sounds, which is what we want, right? Because what's going to happen is there should be a sound for the background. There should be a sound for like when you shoot your laser, what if the enemy shoots back to you? If you have like a level up sound, right? You want to have multiple channels where the music can play or sounds can play. If you only have the main channel and you don't set up multiple and you have the main music playing, the moment you press your button to shoot to play a different sound, it's going to stop the other sound and play your shooting sound. And then it won't restart. Right? And that's not very ideal. So we have to set some channels here. That's what I'm doing here. I'm going to set the background music by saying self.background music. I'm creating a data member for this. And then I'm going to pass in pygame.mixer.sound. And here, the first argument is going to take its file. I'm going to say file is equal to, and then you're going to put open and close parentheses. This is purely aesthetics and just for the sake of having your game look somewhat fun so you can show it to your family or your kids. And it looks enjoyable. So this isn't anything extra. I just want to make sure that you guys can see something pretty cool. And then what you're going to do is you're going to add the music sound for this. And it looks like I did not add that into assets, unfortunately. Okay. Well, if you want to do more, what you're going to do is you can go to Google and you can say something like free sounds. And there's a website, I forget what it's called. Pixabay. That's what it was. You can go to Pixabay and you can find a bunch of stuff here. I'm going to use this for sound effects. Let's go. I'm going to say retro background music. Retro dash background dash music. And this is not exactly how I wanted it. Let's go with music. There we go. I'm just going to go here. Yeah, you have to go to the music section. So when you're here, click on music, type in retro background music. And I believe you could probably use, it's going to be this one. 8-bit retro game music is what you're looking for. 8-bit retro game music. And all you're going to do is just download it. It's free. I think there's some licensing stuff, but you guys are not going to be selling this or anything crazy. It's just for learning purposes. Let me stop my share real quick so I can bring this into my documents. Stand by. Give me a second and I'll show you exactly what I'm doing here. All right. So what I just did is I downloaded the music. After you download the music, one thing that you're gonna notice is that because you're working on a virtual machine, especially with Ubuntu, it's very difficult to find where your folders are at. So if you want to copy and paste into the directory here from your downloads folder, what you're gonna do is you're gonna right click on your directories tab and you click on reveal in file explorer. And it's gonna open up this and it shows you the path. Notice there's like a network, Weasel, localhost, Ubuntu, home. It's pretty difficult to find where the directory of all your stuff is at when you first start working with this. But they should show you where the file location of everything's at. And then from here, you can just drag and drop your music download into the assets folder. So you have access to it. And finally, what I am gonna do is grab a laser sound. I know you guys can't hear because I'm not sharing sound. But you guys can go through these, find something you're looking for. I already have it downloaded, so I'm not gonna waste any more time here of which one I liked. But you guys can go through here and find some sounds that you might want to use. Give me a second to bring it out. Okay. And let me go back to share my screen. So I got my music. It's in my assets. I have background music and shoot one. But once you have it in your assets directory, go into the background music. In the file argument, you're going to pass in the file path to it. So it should be assets / background music .mp3. And now, if I did this correctly, when I run this, you should hear my music. And I don't hear anything, unfortunately. Oh, my bad. I didn't play it. Okay. My bad. I was getting ahead of myself. Once it loads it into my background music, I actually have to play it. So I'm going to say pygame dot mixer dot music dot play. This will play the sound the moment that loads your game up because this is within the game object. Now, if I run this, why do you hate me? Did I do something wrong? Oh, I did do something wrong. Okay. This is incorrect. It will be pygame.mixer.channel. And in channel 0, I'm going to do .play, and I'm going to play the self.background music data member. Once again, we create the channels, we load up the music, then we call the channel for 0, and we're going to play our background music. Now, oh, that's super loud. Okay, my bad. Sorry, that was too loud. Do I have any questions on the background music? It should just be an MP3 file. Have it somewhere in your directory. You set the channels, load up the background music, and then you play it in channel 0. Now, for your bullet, if you want to add a different sound for your bullet, you're going to go to the bullet class. And in your bullet class, you're going to create the data attribute called shoot sound, or whatever you want to call it. Sound effect, no matter. You're going to call pygame.mixer.music.load. And you're going to load assets and then the name of your sound. Sound, or I think shoot one .mp3. It's a little bit different than how you do it in your main. Don't ask me how this works. This is a Pygame thing. I'm just specifically doing this for aesthetics for you guys. If you want to have this ready. But yep, that's how it's done. Let's see how this works. And there you go. I'm going to open up my main.py here for you guys to see both. And while I finish talking, you guys can, just look at the code, see how you want it. or what you might have missed. But you now have the sounds for both the main game and your shoot sound. Just download whatever sound you want for each. But while you guys can do this, that's going to conclude today's class for object or the programming space invaders. All right, that was it. There's more if you want to continue on this assignment. There are a couple of things. Let's see. If you want to continue on this, you are more than welcome to. At the very bottom of the Pygame README, you're going to encounter exercises that you can use to expand on this game if you want to. Everything that was shown here on this class from today and Friday is done step by step within the README. If you want to go back and look at this, you guys can. I would just follow the README step by step. At the very bottom, you'll find some exercises. Like I'll create a feature that allows the enemy class to attack our player. A scoreboard, so you can create some kind of scoreboard that you're going to paint on top of your space surface to show how many aliens you've destroyed. Whenever you kill an alien, you increase the scoreboard, right? So you can do stuff like this. We did exercise 3, which is adding this sound effect. I did that for you guys. You can do like a player thing. If you guys ever play like the Legend of Zelda, the 8-bit version, the retro one, where there's like little hearts in the top left corner. You can do something like that. Maybe add some power ups. So this is all up to you guys if you want to continue on this and make it more of your own. Have fun with it. But yeah, that's going to conclude the Space Invaders assignment. Thoughts, questions?
So as far as the 2 channels, it's not like 3 as in it starts with 0. It's 2 different channels you have possible to happen at the same time.
So what I believe is happening is this is being set to channel 0, and this is set to default main sound.
Okay.
Right. You can create more channels and then add like to, say pygame.mixer.channel1.play. I could probably refactor this code and do this and put it in my bullet class, right? Or in my spaceship class, because my spaceship is the one that's playing this whenever I click on something for shooting, right? I could do it somewhere within there. This is what I was able to come up with in the short time that I had when I was creating this lesson. But you can experiment more with this. There should be other ways to add multiple different sounds. It requires the set number of channels, calling them. I believe I might have done this a little bit differently. I could have probably done something like this, where I said, for example, I think it should have been something like this, where I said self.channels, I think 0. Let's try this. No, did not like that. Yeah. There is a way of doing it. I had to learn Pygame myself to show you guys this, so I'm not quite of an expert on this. Like I said, it's just a helper module to use object-oriented programming in something that isn't something like lemonade stand, right? It's just nothing but straight text. Sometimes it can be a little difficult for new students to visualize, like, what the heck is an object in a class? Like, how is it working? It confuses me. How can this have data attributes, data members, values? What is that? What exactly is that method doing? So this year we're able to create, different objects within each other, objects that create objects, right? The game object is creating a spaceship object, right? We saw that. It's creating bullet objects, alien objects. It's calling on the method of these same objects within the game object. So it's just kind of bringing in everything that you've learned within the last week and a half together, right? So if you want to learn more about this stuff, that's going to be on you, Jason. But I do not want to, waste more time on what's left in the
Can I just have one more question, then I'll leave it alone?
Yes.
Okay, can you scroll up to the channel? So could you if you made this one, would it not work? If you made Pygate in on line 16, if you made that channel in parentheses and made that as a one instead of a zero, would it not work?
Yes. Sorry, super loud. Yes, because
Okay.
like I mentioned, this is playing in the main channel.
Mhm.
We created an additional one. Right. There's one socket already pre-built by default. Right. And then
Okay.
we created a section on the side where we have additional channels. If that makes sense.
Okay.
Um, does that help?
Yeah.
Okay. Yeah, awesome. Show this to your kids. I see you guys have kids walking and whatnot. Hey, look what dad made. I'm sure they'll find it interesting. Uh, but yeah, that's going to conclude today's class for Space Invaders. Thoughts on Pygame and the utilization of Pygame for object-oriented programming? Good comments, bad comments, it's okay.
Yeah, I thought it was cool to see something different than just a text related, thing, kind of like Lemonade Stand, So yeah, it was neat. It was neat to see.
Yeah, awesome. Tim, comments, complaints?
No, it was definitely interesting.
All right. Well, we spent enough time on Space Invaders. We're going to go ahead and kind of move forward. Let's see. Last time, Jason brought up the fact that there was an assignment that we did not cover. So we're going to finish this off and start big O notation right afterwards. And that's pet.py. Uh, let me go ahead and open this up and see what it looks like. Should be lesson 11, pets. There we go. We are done with Space Invaders. Hopefully that was enjoyable. You just got to see a different side of code. Now let's talk about pets. We're going to finish off pets and then jump into big O notation. You're going to write a class named neighborhood pets that has methods for adding a pet, deleting a pet, and searching for the owner of a pet. Sending the data to a JSON file. Loading data from a JSON file and getting a set of all pet species. Right? There is no other file in here. You're going to create it and then add it. The init method takes no parameters and initialize all the data members, which must all be private. So once again, the neighborhood pets, it should be initialized with no parameters, but it be private. The add pet method takes as parameter the name of the pet, the species of the pet, and the name of the pet owner. If a pet has the same name as a pet that has already been added, then the function should raise a duplicate name error. Right? So you need to define this exception class. Right? So essentially, I should be able to create a neighborhood pet class and then run the add pet method. It takes in a couple arguments and it should add a pet somewhere. Let's see, where this is. It doesn't specify the data attributes for the init method, right? The init method takes no parameters and initializes all the data members, but it doesn't say anything about data members, right? So it's up to you to create the data member, wherever you want to call it. And it should be able to add this new pet and add it to a JSON file, right? It should be able to add a pet into the JSON file. It should be able to delete a pet from the JSON file. And it should allow you to search for it, right? So whenever you create this, the init method should initialize a new JSON file that allows you to add pets to it. You run the add pet method. It should check your pets in the JSON file. If it doesn't find it, it's going to add it. If it does find it, then it should say something like duplicate name error, right? The delete pet method takes as parameter the name of the pet and deletes the pet. The get owner method takes as parameter the name of the pet and returns the name of its owner. The save as JSON method takes as a parameter the name of the file and saves it in a JSON format with that name. You can assume the extension, if any, will be part of the provided name. So we have individual methods for save as JSON and read JSON. So what I think should happen is maybe create some kind of data type where you can instantiate the neighborhood pets and then add a bunch of pets and search them. At the very end, you should be able to take all the information that's in this data type, maybe a dictionary, and then convert it into a JSON, right? And then be able to also retrieve the information. And finally, you have another method called getAllSpecies, a method that takes no parameters and returns a Python set of the species of all pets. Is there any questions on this assignment? It's giving you a little room to kind of tackle this in a way that you see fit, right? Because it doesn't tell you the data attributes and so on and so forth. Just know that you should be able to take in new pets, search for them, delete them, and then finally, at some point, save it to a JSON file. Any questions? All right. Time is 7:30. Let's go ahead and take a 10-minute break. Come back at 7:40. Work from 7:40 to 8. And then when we come back, we'll go through a review. I'll see you guys then. All right. Welcome back, everybody. Does anybody want to volunteer to kind of start us off on what they got going on? No one? Was my mic muted? It's okay. Okay.
I can run you through mine if you want.
Were you able to complete it?
Yeah.
Oh, okay. Yeah, let's get that.
The only issue I had was with exporting the JSON, so I had to look up how to do that using what do they call it? A Lambda function. But can you see my screen?
I can.
Okay. So I started by defining a pet class. That way I could just feed instantiated pet objects into the dictionary that I create later. So pretty simple. Do a standard initiation and then give it a couple of parameters for the ones that require name, species, and owner. I defined a repr function as well, but I didn't actually end up using it. And then I got getter for for name, species, and owner. The only one I really used were name and owner later. All right, ignore this. It didn't work, and I ended up not using it. Then I defined the actual neighborhood pets class that we were told to make and initiated, took 0 arguments, initiated a dictionary. I decided to go with a dictionary and then an array or a list inside that dictionary to hold those objects that come from the pet class. So get pet is pretty self-explanatory. You just have to getter method for the entire dictionary to use later. I also created a reset because part of the assignment was you had to be able to import the dictionary from a JSON and replace what you already had. And I figured just replacing it to its starting parameter would be the best way to do that. Add pet is real easy. It starts with the dictionary object and it just goes through the list to see if the pet name already exists. If it does, I'm sorry, if there are no pets, the length is 0, then it automatically adds one. And if not, it checks to see if the pet's already there in that list. If it is, it tells you pet already exists, not going to add it again. Otherwise, it appends it to the list just like it did if it were length 0. Delete, pretty simple. Just goes through, looks at all the pets. If it finds it, it deletes it, and it tells you removed the pet name, bye-bye name. Get owner is just a getter method for the sorry. It's just basically takes the name that you feed it, goes through the list inside the object, and if it finds the name, then it returns the get owner getter from the class that we defined up here. Save as JSON. This one was where it gave me some trouble. So I started by opening a file with write permission and naming it out file. And then I had to find a way to create or to convert the entire dictionary into a JSON. And the way I found that, I just went to Stack Overflow and looked and found out a Lambda method, which is basically an anonymous method that you can feed parameters to. And I was able to dump the dictionary using outfile.write to a JSON. Then for reading, I would read the hard-coded pet JSON name, pets.json, as in file, load it to make it usable, and then for each item in the list, I was able to go through it and then call or append a new instantiated pet class into the list that I had created earlier, and then just printed it just to make it look nice. And the get all species created an empty list, went through all the pets in the dictionary, and then everyone that it found, I just appended to that empty list or to that list the get species getter from the class that we instantiated before. And then these are all the tests.
Okay. Your dump method, it is singular, not plural, which is why it wasn't working.
Oh.
Yes, these are two different ones. Dumps and dump,
Mhm.
different. If you take off the S, you can run it without having this lambda function.
So it didn't work. And I think that's because initially when I was writing it, I tried to inherit the dictionary class into the class that I created. And that wasn't working. So then I killed it. And this is the only way I could get to find it. But I'll try that next time.
Okay. I don't know why my thing's still writing. Okay. All right. Pretty good. Pretty straightforward. I can see that you guys are getting better at it. That was a lot faster, Tim, than the other assignments. Hopefully everybody was able to finish it off. But without further ado, we're going to use the last hour of our class lecture to talk about the next assignment, which is going to be Big O and common problem solving patterns. Go ahead and share my screen. Now, let's go ahead and start. So, how to judge quality, right? Imagine we have multiple solutions to a coding challenge. How do we decide which solution is best, right? Who can take a guess at this? We kind of talked about it a little bit earlier, but what defines something as being the best solution to a problem?
Something that gets it done with the fewest resources used and quick.
Yeah, that's a good explanation. Who here has used LeetCode before? No? Okay. LeetCode, I'm sure you guys use like Code Wars or something fairly similar. I think Reply has challenges too. But it is very popular within the industry as a way to practice coding challenges, right? The most common one is LeetCode 75. Someone was able to create a list of the top 75 most used questions in coding interviews, right? And it's grouped together by categories. I'm not signed in, so you don't see my performance on these, but I've completed a large majority of these. But you see here how they have them categorized by sections. You have challenges that handle arrays and strings, two pointers, sliding window, and these might not mean anything to you guys. We're going to talk about some of these throughout this week. But there are different types of coding challenges out there. Each have their own approach and trick to it, because realistically, that's honestly what it is. There's a trick to most coding challenges, and the way that you reach what solution you need to use is usually determined by the wording of the question. A lot of times, the wording of the question will give you keywords of how you should approach said problem, and what type of problem it really is. These get more difficult as you progress through the different sections. But the main reason why I'm showing you this is because when you open up something like a coding challenge on LeetCode, what you'll have is, and let me just show you. I'm gonna copy and paste something here. I'm not gonna go to the problem itself. Let's go with Python. You can see the solutions of the problem that you're working with. And I'm just gonna copy something real quick so you can see how it works. But when you run a solution, you can click run. And it typically has like 3 test cases you can use. You need to log in to run or submit. Okay. All right, give me a second. Let me log in. Stand by. Second. Okay, let me go ahead and share again. I have some submissions. I've already done this. I can pull up my previous submission. This is what you're gonna get. You're gonna get something very similar to this. Let me see if I can see the code. Is this the code I use? No. Here it is. Here's the code I use. So my action was a lot simpler than what I initially had here. This is my solution and how I figured it. You can see here how many times I submitted the solution and how many times it worked. And the reason why I submitted so many times is I usually use it as an example. But you come to this problem and you go ahead and you figure out the solution. This is your kind of like your IDE. This is where you write your code. When you're ready to see if your code's working, you click run. And there's already by default a couple test cases that you use. And we see here that we run it. And it'll run your test cases. And it'll tell you how many test cases you passed. Right? If you pass, you will see green and it says accepted. It tells you what you inputted, the output, and what was expected. Right? It even tells you the runtime. How fast did your code take to reach the solution for this case? 15 milliseconds for this one, and honestly, 15 milliseconds for all these. Now, when you get ready to see if you can submit, right, I completed these challenges, so I passed the 3 sample test cases. I'm ready to submit my answers to see if I solve all these different test cases. You can submit, and then it'll run through the solution. And you will see this window. This is going to take your code and it's going to compare it to everybody else that's completed the problem that you're working on. It's going to show you how you compare to others, right? In terms of efficiency, we have runtime and memory. Runtime is determining how fast your solution ran. And we see here that mine ran at 12 milliseconds to answer all the different test cases. And it shows you how many other people were in the other categories. So there are just a handful that were running at 6 milliseconds or less. Only 0.15% of the people that solved this problem have gotten it to like 1 millisecond, which is pretty impressive. And then you can also see the memory that you used. So I beat 83% of everybody else that's done this question. And of the memory, I only beat 9%. So although mine was more efficient in time-wise, memory-wise, I took more memory than other people. Right? I only beat 9% of other people in memory. So this tells you the efficiency of your code, not only on the time, or I guess runtime, but also on memory or space. Right? So the time complexity and the space complexity will give it to you. It'll analyze your code. Right? And what we are going to be talking about is how this is determined. How do you determine exactly the time efficiency of your code and the space complexity? And we say space because we're talking about how much space of memory your code is taking when running it. Big O notation allows us to use some kind of measurement to figure out how efficient your code is. Big O is a mathematical notation that allows us to compare algorithms to one another. Here we have a chart that you're going to see multiple times throughout this lecture on the different types of complexity. The fastest complexity is at the bottom, and then the higher this goes up, the more inefficient the code is. And it's determined by these I guess, equations. Big O is referring to the O here, the mathematical notation of how it's written out. Now, why is this important? Well, for one, it's important to have some proper vocabulary to be able to not only scientifically but intelligently talk about code and its efficiency. So Big O was a way that we were able to talk in similar terms about how efficient code is. It's useful for discussing the trade-offs between different approaches to a given problem. At bigger companies, you will be dealing with very large data sets where the implementation of one algorithm over another might save you a couple of hours every time it runs, therefore also saving you money. Now, most of the code that you'll be using now, and even during the cohort, might not seem like a lot, right? When you start working in some corporation, it's gonna really matter. What you might also encounter is whenever you get to your technical interviews, you will go through the first part of coding on your problem, and if you are successful in the coding challenge, your interviewer more than likely is going to ask you, what is the time complexity of your solution? If you can speak intelligently of what your solution is doing, that's going to be big bonuses for you. They might also ask you, what can you do to improve the time complexity of your solution? So knowing what different approaches you took on your code and what the time complexity of it is really important to make sure that you know what you're talking about. Now, here we have two coding examples. We want to write a function that doubles the integer that is passed in. The question is, which one of these functions is better? This one, well, for first and foremost, this function takes in a argument, which is num. It creates a variable called total. It sets it at 0. And then we start a for loop. We say for something in range of the num that's being passed as an argument, I want to add 2 to my total. And then I want to return total. On the other code snippet, all we're doing is taking num and returning it multiplied by 2. Which one of these do you think is more efficient and why?
Knowing nothing about this, I would say the second one because it only has a single parameter and it only has one operation returning that parameter times 2 instead of multiple variables and going through a loop.
Well, you are correct. The one on the right is more efficient. For one, we are not creating a new variable. We're not saving anything in memory, so we're not taking any kind of memory space. Secondly, the one on the left is bigger in time complexity because of the fact that we are starting a for loop. Here, imagine num is the number 1000. If we wanted to get the total of that, then we would have to loop through 1000 times until we doubled this number in size. So, best case scenario, this number is 1. And all we do is run a for loop one time to make it 2. Worst case scenario, this number ends up being 1000. So we have to run this for loop 1000 times to reach the same outcome that this one reached. This one did not start a for loop. It just took the number right off the bat and just multiplied it. This did it in one step. Whereas this, the steps that it took was determined by the size of whatever num is. So what do we mean by better? Do we mean what code is faster? Which one uses less memory? Or which is more readable or even less lines of code? Thoughts?
All of the above.
I would say yes, all of the above. But there is some that I feel are way heavier than others. How would you rate these? From number 1 being the most important to the third being the least important.
Depends on what your restrictions are. Like are you limited on time? Are you limited on memory? If you're trying to
Oh,
get done, whatever you're trying to get done, if you're trying to get it done quickly, then faster is going to be better if you're not limited on memory. And lines of code don't really matter. But if you're trying to be efficient and you're pushing a bunch of data over a network using JSONs or something, then you're going to want to use less bandwidth, and then memory is going to be important too.
you make great points. Did you guys grow up with a PlayStation? PlayStation 2? Okay. I grew up with PlayStation 2. Before PlayStation 3, if you wanted to save your game, you had to purchase a memory card. Right? If you ever were around any kind of game consoles and you were around PlayStation 2, you would know that you had to purchase a memory card. They came in different sizes, 8 gigabytes, and so on and so forth. They were very expensive. I think when I was young, my parents bought me, I believe, like an 8 gigabyte or 12 gigabyte memory card, and it cost like $15. I'm sorry, not 15, $50. It's a very expensive memory card. About a year ago, I went to buy a terabyte from the store because I needed to save my games on my computer. It cost me $20 for a terabyte, somewhere around there. I think a little bit less. Memory has become significantly cheaper thanks to our technological advances. If I would have asked you this question 20 years ago, memory would have been a pretty big issue. These days, fortunately, memory is not as big of an issue as we think it is. It still matters, of course, but it's not as important as it used to.
But are we talking about memory or storage? Because those are different things.
Well, storage, right? You still want to be able to save your stuff somewhere, right?
I was talking about memory and loading lots of data and variables into memory in order to save that would be important because if you overload your memory, granted you probably have, 20 gigabytes of memory or more.
Correct. These days, what really matters is your time complexity. What code is faster? Readability, I would argue, is third. Your memory will be second, and your efficiency, your code, your time complexity will be first. But at the end of the day, let's say your code is super fast. If no one knows what the heck it's doing or how it works, it can bring issues right in your team when it comes to debugging or even scalability if you want to increase your project. So all three of these play a factor into what code is faster, or I'm sorry, better. But I would argue time complexity is the most important from these. But regardless, readability and memory are still something to consider. Now let's talk about which is faster. How is that determined? Normally, as humans, we determine faster as in what takes less amount of times. In code, we don't necessarily mean time. What we are referring is to steps. How many steps did your code take to reach the solution? Not to be misinterpreted with lines of code, right? Not to be interpreted with lines of code. If I run this solution here, I'm not always going to get the same time. Let's look at this one, for example. The first time I ran this in my demo, it ran in 12 milliseconds. Let's see if it changes. Oh, my bad. 12 milliseconds. I'm going to run it again. 20 milliseconds. This time, I only beat 26% of the people in my code. Time is not reliable. It's the same code ran 10 minutes apart on the same computer. So we do not measure by time, we measure in steps, right? Hardware can be different. If I turned on my computer, turn on tomorrow, it's going to run differently. Right? We don't measure in time, we measure in steps. So far, so good. If you run two different code, or you run the same code, two different people run the same code, they're not always going to get the same time, right? There's different factors that take into play, which are not something that we need to really think about right now. The main thing here that we need to focus is that time complexity is determined by this the steps taken into your equation. We don't use time because different computers will record different times. Even the same computer, as you saw, will record different times. For very fast algorithms, the time measurement of a computer might not be precise enough. So we talk about steps, or in another word, iterations. How many iterations did your code go through to reach the outcome? In this code example, the function of double that takes a num, it did one iteration. It just took the number and multiplied it once by 2, right? Whereas in this code, the amount of steps it took was the same as the size as num, right? So this could take 1 step, or it could take 1,000 steps, all because of whatever the size of num is to reach the total of doubling. Whereas this one, no matter how big num was, whether it was 1, 100, a million, 10 billion, is going to give that number and multiply it just once. So time efficiency, this was much better. Or I don't even think that's a word, much faster. Sound good?
With that for loop that you have right there, it says for underscore. I've never seen that before. What is the difference between that and just using a random variable?
Nothing. It's the same thing. It's like saying for I, for X.
Okay, I didn't know you could use that.
Yes. So how many operations does this function run if num is 10?
Five.
Why?
Based on the number. I mean, plus equals, 2 times 5 is 10, so.
It's going to take 10, Jason. We're going to run this for loop up to the range of 10, right? Because num is 10. So it's going to do this 10 times, total plus 2, making our outcome 20, right? Because we're doubling the num.
Oh yeah, that's right. Yeah. It's late.
Okay. It's okay. I understand. It's going to take 10 iterations, right? Whereas this one, no matter what the size of num is, it only took 1 iteration. Big O notation is a way to formalize fuzzy counting. It allows us to talk formally about how the runtime of an algorithm grows as the input grows, right? The input was like num, where whatever you're passing in, the size of the input will end up determining most of the time what your outcome is and how long it took. Specifics don't matter as much as the broad trends of the function in question. Here we see another version of that same chart we saw earlier, but in a graph this time. It shows you the formula and then the way that it's called. O of 1. I'm sure you probably already heard this before someone say it. O of 1 is constant time, right? It does it instantly in 1 iteration. That for loop you saw was O of n, right? The O isn't really something you have to really worry too much about. Like, what does O stand for? That's just the notation that we use to specify, hey, this is referring to time complexity or space complexity in general. What really matters is what's in the parentheses, the 1, right? This is called O to 1 because they did it in 1 iteration. O of n is linear. It does it in n amount of iterations, n being any possible number that you pass in as input. And it could be 1, best case scenario. Worst case scenario, it could have to loop through the entirety of that range up to 1,000. It grows linearly depending on how big n is. Back to our 2 examples. Big O of this function is O of n, right? N being X amount of iterations, right? N can be 10, it can be 20, it could be a million. Whatever n is going to determine what the worst case scenario is. When we talk about iteration, we typically talk about worst case scenario, right? Because sure, maybe one time when you run this, n is the size of 1, therefore making 1 iteration, which technically you would think, oh, well, if the num is equal to 1, then shouldn't it make it O of 1 because it's only going to be one iteration? Technically, the outcome would be 1. It would be one iteration. But we talk about worst case scenarios, right? Because right now in this situation, you're using 1 as num. Some other time you might use a million, and we have to take that into consideration. We're taking the worst case scenario as the outcome of its time complexity. Whereas big O for this one is O of 1, because no matter what size num is, it will always do it with one iteration. It stays constant every single time. Worst case scenario, it will always do one iteration. That's why it is O of 1, constant time. This is O of n, linear time. Everyone still with me? Broad trends examples. Here, what do you think is happening, and what is the time complexity? No guesses.
Is it O to n like it is at the bottom? Because there are two functions it's going, and they're both based off of different variable lengths.
You would think so,
Wouldn't
but it is
wouldn't
not
wouldn't it just be O of n just to keep it simple?
correct. It'll just be O of n. Sure, there are two for loops. These don't interact with each other, right? Worst case scenario will always be whatever the size of num is. If it's 1,000, it's going to do 1,000 iterations here and 1,000 iterations here, more than likely. Worst case scenario for both of these.
If they were nested, would it be different?
Yes, that is
Okay,
correct.
that makes
If
sense.
if it was nested, that's when it gets more complex. Broad scheme of things, this is just O of n. Doesn't matter if there's 8 other for loops that come afterwards, it's still O of n. Worst case scenario is that for loop being max count, worst case scenario of whatever num is. Which brings me to the next problem, Tim, right? What happens if they're nested? Well, now it becomes O of n squared. O of n squared. It increases the time complexity. Let's go to todraw.com. Go to a list 0, 1. No, let's go 1, 2, 3, 4, 5. This is our list. My code is going to try to loop through these and print these out. If I say for I in range of the length of, say, nums, print I. What's worst case scenario of this?
5.
5, right? The length of this is 5. Worst case scenario, it has to go through every single one of these. So that's 5 iterations. It prints out 1, then 2, then 3, then 4, then 5. Now, when I add a nested for loop, this changes. For I in range of I, let's keep it simple. Let's say J. Let's remove this. We start the for loop to loop through the for loop once. And every time we loop through, we're going to loop through it again. So this goes from 5 iterations. The first time this prints out is prints out 1, comma 1, 1, comma 2, 1, comma 3, 1, comma 4, 1, comma 5. And then it gets to 2, 2, comma 1, 2, comma 2, and so on and so forth. This just squared the amount of times that this is going to do, or this is going to iterate through, all determined by the size of whatever nums is, right? The outcome of this worst case scenario is going to multiply this by 5. 5 times 5, 5 to the power of 2. So it went from 5 iterations to 25 iterations, because for every number that we loop through in the outer for loop, we're going to loop through again for the same length of whatever nums is. So a nested for loop increases the time complexity of your code by squared. Worst case scenario. All right, so a nested for loop is O of n squared. Any questions? How many operations this function run if the num passed in is 10? And we just kind of saw this. If it was just a normal for loop and we did for I in range of 10, how many iterations is that?
Well, then it would be 100.
It would be 100, correct? Right, because we just squared the. I'm sorry, we did to the power 2, right, for this nested for loop. So O of n squared. This made it from 10 to 100. Once again, the graph again. I told you, you can see this graph all day in this lesson. Right? This one is not my favorite. This is very, very misleading. A O of log of n is not accurate. The way that it's represented here is not this close to O of 1 constant, unfortunately. O of n should be right here, but it's not. So this is not my favorite graph, so let's go ahead and skip this one. But you're just going to see it multiple times. There's different examples that you see there. Honestly, the best example of time complexity is this one right here. As the input size grows, you can also see the computations of how many times it's going to go through it. You see here that this one gets better. Log of n gets better as the size increases. And we'll talk about how this one works later on. O of n, it's linear. It stays constant depending on the size of n. O n log of n gets worse as the input size increases, and so on and so forth. Remember broad trends. What happens to a number of iterations as the input gets really big? For one, constants don't matter. If you have O2 of n, what do you think O2 of n is? You kind of already saw it. It is 2 for loops that are not nested to each other, right? They're not nested, but there's 2 for loops within your code. O2 of n will just be O of n. What if you have a fixed input, 500? That is the constant time, right? That's going to be O of 1. Doesn't matter if you what's the way I can put it? If you add 1 plus num, right? If num is equal to 1 or if num is equal to 500, it'll always be 1 iteration, right? So O of 1 or O of 500 are the same thing. Doesn't matter if you have one of them or 500 of them, right? If you're adding a number multiple times throughout your code, but it's not within a for loop, it doesn't matter how many times you add it up throughout your entire code, it will always be O of 1. And we'll see that in a little bit. This one is showing 13 nested for loops. O of 13n to the power of 2 is 13 nested for loops. That does not matter. We just count it as the fact that it's just a nested for loop. So that's O of n squared. Smaller terms also don't matter. O of n plus 10. This is an iteration that might have like 10 items. N could be 10, 100, or 200. Even if you do plus 10. The worst case scenario is determined by how big n can get. So even if it's n plus 10, it's still going to be O of n anyways. This is 1,000 for loops, not nested. But all these for loops, you're going to add 50 iterations on top of them. This is still O of n. They're still for loops. This is one nested for loop, right? And then we have an addition of 5 other loops. And then you're increasing what it looks to be the amount of for loops by 8. But the worst case scenario is a nested for loop here. So worst case scenario is O of n squared. Arithmetic operations are constant time, O of 1. Any math, multiplication, division, subtraction, addition, it's a constant time, O of 1. Going back to the multiplication, that double of num, and they return the multiplication of num, constant time, O of 1. Variable assignment is constant time, O of 1. So, even though this created a variable, this is O of 1, this variable didn't really matter. The moment we added this for loop, it went from O of 1 to O of n squared. Accessing elements in an array by their index is also constant. Same with objects and dictionaries. I want to reiterate that. Accessing elements in an array or a list by their index is constant time. By their index. This is not saying doing a for loop and then finding an item if it's equal to the item that you're looping through. This is accessing it. If I say, let's say I have a list called nums. If I say nums index 3, that is constant time because I went straight to the index. I didn't do a for loop. I accessed it directly. Accessing objects or dictionaries, right? Objects, when they say object, we're referring to JSON, right? Because that's what we call them in JavaScript. And dictionaries is their equivalent of it in Python. It is constant time because we are accessing it by its keys, right? It goes directly to the key. It uses the key because it's linked to an address. We're not having to search for it. We know where it's at. Same thing, like you have a bunch of cupboards, right? Yeah, a bunch of cubby holes, and there's pictures on these cubby holes of the items that they have stored, right? Let's say I have a toddler, right? He has a bunch of cubbies with different toys. Let's say one of these toys are Lego blocks, right? Those Lego blocks, that picture is the address. So if I want to find the Lego block, I don't have to guess where it's at. I just look at the cubby, I look at the picture of the Lego block, and I open it up. Right? That is constant time. Right? That is what a key is in dictionaries. O of 1. In loops, the complexity is the length of the loop times the complexity of what happens inside the loop. Right? So if it's a nested for loop, that's what it's referring to.
So things like assigning values to variables within a for loop doesn't add to the complexity. It's just the iteration of the loop.
Correct.
And how do I understand that dictionary keys are a single O1? Makes sense. What about dictionary.get methods?
That is, I believe it's O of 1 because it's using that key to try to access it. And if it doesn't access it, then it returns it to you. That should be O of 1. That's a good question. What is the time complexity, or big O, of the following? O, n plus 10.
O of n.
O of n. N could be 100, n can be 1,000,000. Worst case scenario is always going to be the amount of n, even if you only add an additional 10 to it. Because n, it can be subject to change, and it makes it O of n, right? Linear time. How about O of 100 times n? What do you think this is reading out?
It's just returning 100 times whatever n is.
Correct.
So O of n.
O of n. Right? It could be 10 times 100. Worst case scenario, n could be 1,000,000. Now you're multiplying that by 100 too. O of n. O of 25.
O of 1.
O of 1. It won't change. Worst case scenario and base case scenario will always be 25. O of n plus n plus n plus n.
O of n.
O of n. Once again, it would increase linearly depending on the size of whatever n is. O of n squared plus O of n cubed.
O of n cubed.
O of n cubed. Correct. That's 3 for loops, all nested within each other. Function with one set of nested loops.
O n squared.
O of n squared. Correct. Function with 10 unnested loops.
O of n.
O of n. All right, you guys are getting it. Okay. What about this one?
Looks like O of n.
O of n. It's a for loop. And depending how big n is, or num, will determine how many iterations we do. What about this one?
Still O of n.
Why?
Because it's just one for loop. The range is more complicated, but that shouldn't change the for loop complexity.
It is O of 1. Num, notice here, they're taking this min function. Right? No matter how big num is, this will always return the minimum. Whether num is 20 or 50, it would never be greater than 10. So it's actually O of 10, which is O of 1. I'm pretty sure. Let me just check.
But it's still in a for loop.
Yes. It's not the for loop that really matters, it's the amount of iterations it's doing.
So the min isn't going to be no more than 10. So wouldn't it be between 1 and 10? It's going to run 9 times. Plus 1, 10. It's going to run 10 times.
It's going to run no more than 10 times. No matter what num is. I mean, num could be less than 10. It'll take num then. Oh, my bad. But because there is a max to this, it does not grow linearly, right? It cannot grow more than 10. It is hard set. This would never be more than 10 plus 1, which is 11 technically, right? It is of constant time. It's a little tricky.
That still seems like O of n to me.
Why?
Because it's in a for loop running more than one time. Isn't O of 1 just like return n plus 2 instead of for n in range?
Say that again?
O of 1 would be, please correct me because I'm probably misunderstanding this. You define the method num, return num plus 2 would be O of 1.
Num plus 2 is
If you got rid of the for loop
uh-huh.
and just returned num plus times divided by whatever, and it only ran one time, that would be O of 1. My
Yes,
understanding was anything that runs within a for loop more than once is going to be O of n.
and that's where the confusion gets, right? It's not necessarily the for loop that's the issue. It is the size of the input. How is it growing, right? Because
Oh,
no
it's only
matter,
printing n. It's not manipulating.
right, it is not going to get any bigger than 10. It is constantly less than 10. When we say O of n, we're referring to n being the size of the input that can grow depending on whatever n is. Right? There's worst case scenario. Worst case scenario here is O of 10, which that's a term in regards to broad spectrum, right? The broad trend is it is O of 1, because no matter what, whether num is a million, 2 billion, it will never be more than 10. It's not growing linearly. It stays constant to less than 10. It is a little tricky. Right? The min here is the key on this one. The fact that it'll never be anything more than whatever 10 is. No matter what num, whether it's, a million or 2 billion, it is constantly no more than 10. Therefore, making it O of 10 technically, but we simplify it because we're talking broad trends here, making it O of 1.
Okay, so if the min were the max, then it would be O of n. Because num could
Cor-
be like 1 million or 10.
correct. Yes. The keyword here was a min. I know it's a little tricky, but you guys are doing good so far.
No, that makes sense. So if you just had a fixed for loop and it just said for n, or
For I in range of num, yes, that would be
that would be also
O of n.
yeah.
Because n at that point, there's no limit to it. It can be as big as num could possibly be. But here,
Or
there is a limit.
or if you just had a range 1 to set number without the min in there, like 1 to
Yes,
20, then it would still be O of 1 because 20 is the absolute known maximum.
correct.
Okay, I get it.
What is the time complexity for this one? This was significantly easier.
I just don't know if you're trying to trick me.
Where
I'm not.
I'll just say O n squared.
It is O of n squared. Yes. Because R could be 1 to 1 million. It can grow linearly. And depending on how big R is, it's going to determine how big elim is. So elim can grow linearly as well, depending on how big R is. So therefore, when we start this nested for loop, because elim can be n amount of inputs, it grows linearly with R, then this is O of n squared. All right, we're going to take our stop here. Before we hit space complexity, I don't want to start another subject. We'll stop halfway. Do I have any questions on time complexity so far? What is the time complexity of this one?
I'll say O of n.
O of n is correct. Good stuff. Well, I'm going to go ahead and stop the recording here.